Welcome back. We are going to be looking at the Earthquakes and Plate Tectonics Lab Prep video. So I'm going to be walking through the media you'll be using for this week's lab. You can do this at home. Please start it before your lab session because I will be in lab answering questions and will be online the whole time. So if you wait till the last minute, you might not get your answers to your questions because I will be in class. So start it a couple days ahead of time. That way you can email me your questions and I can get back to you before the due date. So the media you'll be using for this lab is located on our course page. If you scroll down, and if you're watching this and we're not using Moodle, I will show you how to get to it as well. So here is your Earthquakes, Plate Tectonics lab, and you click on the Lab 7 file, and there you go. Now if you're using D2L, you're going to be going to the course page. You're going to be going to the content part of the course page here and heading down to Earthquakes, clicking on the lab, and it should look very similar here for either course. I'm going to go back to Moodle though. So you'll see a link to the Plate Tectonics and Earthquakes file. That's what you're going to use. And please note the password and username you'll have to enter. Don't forget that. I've already opened it, and here it is. So you can do the majority of this from home. I'm just going to make this a little bit bigger here. If you don't want to use the media, I suggest using it, and if you see problems or you're having trouble getting it to work, which can happen, I will provide you with some of the paper stuff so you can like handwrite it and bring it to lab or scan it if you're going to do it from home. So to kind of walk you through, so this is the intro page you're going to come to, a little introduction. So anything in green, any text in green, you should be able to click on. Okay. So if I click here, so that you're going to walk through the directions document. It's going to tell you exactly what you need to do, where you need to click, and then you're going to have your answer file where you're going to type in all your answers to the questions. So it will walk you through it, but I also wanted to show you what to do as well. So in Module 1A, Simulated Earthquakes, here, your instructions, read through it all. You can click on these, make your taps. You see the earthquake, or the waves that are produced. And here you can see how things change. There you go. So as you click on these things, you're going to get different graphs that pop up. You'll take your measurements, answer your questions based on what you see there. It's pretty basic. Part 1B, you have 3 different earthquakes, seismograms here. And basically what you're going to be doing is, if you scroll over the green area, you see some lines that get drawn on here. It's measuring the amplitude. It's the top line. So each part of this, these 3 different sections here, you can see how we've got one wave pops up here. You see disturbance, you see another disturbance, and you see a third disturbance. And when you scroll over each of those, you'll see that it tells you the amplitude of that disturbance, 0.2 millimeters, and then it gives you a range for how long that earthquake lasted, so how long that disturbance lasted. And if you follow those blue lines down to the bottom of your screen, down here, you'll see where the time is. So for instance, if I scroll over the third one and this third disturbance in the second seismogram, it's a little different. So you're going to be recording this information and make sure that you are scrolling over each of these to determine how long it's lasting, and use this scale at the very bottom. Okay. Next part 2, this is where things can get a little tricky. What you're going to be doing is using 3 different seismogram stations. You're going to be determining the epicenter of an earthquake. So you have 3 recording stations. You can see those seismograms here, Portland, Seattle, and Spokane. And we're going to be using the data we get from those to determine the magnitude of the earthquake and where it occurred. So for this part, please make sure that you're paying attention to the city name and the data you're getting from it. So make sure you're reporting your data in the correct boxes on your lab. This is the most common thing that people do wrong, and then they get the wrong epicenter and things don't line up and they get really confused. So please note same exact names on these and make sure you're recording them in the right spot. So we can click here, show an example, and I have to hold it down. So if you notice here, we've got a seismogram that is dragged over onto the curves, and you're going to line up the first earthquake wave with the P wave curve and the second earthquake occurrence with the S wave curve. And if I show you an example here, let's say we use Seattle. I can actually pick this up and drag it over. And what I want to do is line up the bottom with the P wave. So you see how I've lined up the first disturbance with that blue P wave curve. And then I want to match up this disturbance with the S wave curve. So I need to pick it up and carry it over to where they line up, and then drop it. And then I can get time by following this over to the side. I can get the time in seconds, and I can get the distance down here. So make sure you take those two recordings, report them on the Seattle chart on your lab, correct city, match up with the right ones. And then magnitude and distance graph is the next thing. So once you get your data, you can take this off and grab the next one and put it on, move it around. Okay, so that's that part. Magnitude and distance graph. So here, what you're going to be doing is using that arrival time distance. So back here on your travel time graph, you plopped the sky over here on your graph. I don't know why the red line's showing up. Ignore it. And you're going to take the difference between these two times, and you'll do that on your lab file. So you'll get a time between those two arrival times, and that's what you're going to put in the magnitude distance. So if we type in, let's say, our arrival time was 30 seconds, and we have one line placed there. And then over here, you can measure your amplitude, and you can say, okay, my amplitude was, maybe it was 50 millimeters, and then this was 30, and then it will draw your lines across. Sometimes it doesn't quite work right. This is where if you're typing your numbers in, things aren't working quite right. Now I'm just picking random numbers, which is probably why they don't working. You can drag these. You can click one spot. I'm not sure why it's not quite working right. So this is a part where you might have to take a ruler to your screen, draw it up, and hold it up. If you have a 40-second amplitude arrival time, 2 millimeter amplitude, you hold your ruler up, and you can get your magnitude in the center. So if I click on show example here, this is kind of what should happen. So if you're having problems typing in the numbers or clicking on it, just break out a ruler, or you can use the paper one that I will provide for you. So where that line crosses the yellow axis in the middle, that's what your magnitude will be. So you'll record that for each station. Okay? And your amplitude is what's going to come off of your travel time graph. So if I go back here to seismograms, you'll be getting your information off of these. Okay. So that was our magnitude distance graph. Now we are going to take a look at the epicenter locator. So this is where you're going to be using the distance to the epicenter. So when we used our travel time graph here, we got a distance to the epicenter. That's the number that you're going to type in. Now, note again, please, cities on the top, because you're going to be typing in the data for each. So you'll say, oh, this was 100 kilometers. Draw, and it draws a circle. Seattle, let's say it was 800 kilometers. But get rid of that. And we're going to draw it. There's another one, and then Spokane, we'll say 50. Now these are obviously not correct. You want your circles to overlap, so make sure you're putting in the correct numbers in the correct boxes. And then wherever all those circles overlap, let's redo this one. And let's do this one. Ooh, not 2,000. 200,000. Click on draw. And it won't redraw it for some reason. So you might have to get out of it, go back in, redraw your numbers, and then you can plop a latitude longitude grid and get the exact latitude longitude of where they intersect. Now, you might not get them to totally overlap nicely, so you're going to have to take the point that's equidistant from all of the circles. So where, if you were to extend them a little bit, where are they closest together? Okay, so don't stress out if they don't totally overlap, because they might not. They might just be really close to each other, and that's fine. So you can just get an estimation of where your epicenter is located. Okay, now, and this is another one where I'll have some paper where you can actually use a compass and draw circles to see where they overlap as well. So you can do it either way. The last part, 3A, we're going to be looking at the Pacific Northwest. So this is showing you the different provinces and geological features that exist. I click on tectonics. You can see the different plate boundaries. Click on earthquakes, and this is where we have all the earthquakes, showing you the approximate magnitude in different colors and symbols. Okay. So if you're being asked to say, okay, where are our highest concentration of earthquakes? You can use geographic locations. You can use plate boundaries, where they correlate to. Both of those would work. And the last one, Pacific Northwest surface. This is where we're taking a cross section, a slice through this part, through Seattle. You can see what's happening below the surface, and then we can click on earthquakes, and we superimpose earthquakes over that plate tectonic boundary, and then you're going to be answering some questions relating to why you think these clusters, so there's a cluster here, 2 and 3, so why those 3 earthquake clusters exist. And that is that. Back to the introduction. So if you have questions, please email me, and make sure you start this ahead of time, before lab, if you are planning on either leaving early or not coming at all, because I need to be able to answer your questions via email if you're not coming. So, good luck, and I will either see you in lab or see you online.